Good evening, everyone. Welcome to this session on live interactive session on programming in modern C++. Uh, I request everybody to turn off their mic and video. Okay. If you have any question, you can unmute and ask. A lot of people are still joining, but we will begin anyway. Okay. So these interactive sessions, it will be held every Tuesday from 6 to 8, so 2 hours for 12 weeks. And this is the Google Meet link which will be shared by NPTEL every week. And so first, in all of the sessions, we'll briefly go over the previous week's material, and then we'll solve a few problems. And in between also, if you have any questions, you can ask. You can ask questions on anything. Okay, so like that week's content or the previous week's content, or even if you have studied future week's content also, you can ask. So in all of the NPTEL courses, we have a discussion forum which you can access using this link. Like, you open the course page, and on the right you have this ask a question button. From there you can access the discussion forum. So let's begin. So we this is week one's summary. So sir covered the history, importance of C++. Then we have header inclusion, IO, math library, loops, bool data type. We also have arrays and strings, and we have sorting and searching, and we have stacks and other data structures. So this is a C++ hello world. Uh, Excuse me. Okay. So how do we write this hello world program? Uh, First, we include the IO stream header. So this will include the basic input output statements such as std out and std in. Then we write the main function, and in the main function we write std colon colon out, and then this angular brackets, two angular brackets, and then hello world, and then angular brackets, and then uh, std endl. So you can see that this std out, this is like a output streamer. So anything that you can think of it like this, these angular brackets, these are like a kind of arrow. Okay, so anything that you direct towards out, it will be printed onto the screen. So this hello world will be printed, and then end l ends the line. Instead of end l, you can also write this backslash n in quotes, that will do the same thing. And then we write return 0 to end the main function. So how do we compile it? We assuming that we are using the GNU C++ compiler, we will write on a terminal, we will write G++ and the name of the file, which is hello world.cpp, and then we write hyphen o and then hello world. So this G++ compiler will compile this source file and create a executable known as hello world. So on a Linux machine, this will be simply hello world. On a Windows machine, it will be hello world.exe. And now to run the file, we simply use this thing dot slash hello world. Now this is for a Linux machine. For a Windows machine, it will be dot slash hello world.exe. Okay, somewhat like this, dot slash hello world.exe, and the output will be hello world. So any questions up till now?
No, sir.
Okay.
Good evening, sir.
Yes, Amit.
Sir, there is one question, sir. Sir, actually, I don't know about the difference between the slash n and endl. So, can you please explain what is the basic difference between slash n and endl? Working culture both are same, but what is the basic difference?
Uh, like I don't know the difference in detail. Okay, I mean they both end the line, but I don't know the detailed difference.
Okay.
So these are some differences between C and C++. So you can see that in C we write hashtag include stdio.h, but in C++ we write include iostream, and then in C we use scanf, but in C++ we use std colon colon c in. You can also see that we can in C++ we use this input and output streaming operators. So this is an input streaming operator, this two angular brackets, and this is the output streaming operator. So you can see that the C in, it sort of passes some value to x. Okay, so these are like arrows, whereas in the case of C out, the x is passed on to C out. In scanf and printf, we also have to specify the format. So here percentage d means that this should be a integer. So percentage 2 percentage d means that both are integers, and then we write x and y. So that works like that. But in C in and C out, the type is determined from the type of the variable. So if x and y are integers, then integers will be read. But if x and y are float or double, then that correspondingly that will be read. Then we have printf, and in printf also you can see it is similar to scanf. We have to specify the format, and then we specify the variables which printed. Whereas in the case of we in the case of C++, we just pass the pass the things. Okay, we pass the variable, then we pass a space, and then we pass endl. So it determines the type from the type of the variable and prints it accordingly. Now to include the math library in C, we write as include math.h. In C++, we write include cmath. Okay, so we include cmath. And then one other difference is that um, if we have to use the math functions in C, we write square root x, but in case of C++, we write std colon colon square root x. So the difference is that all the C functions which are included in C++, they are in the std namespace. So uh, before using those functions, you have to uh, put std colon colon in the beginning. Now we go to some more differences. So in C, suppose we have to use an array, we write as int arr 100. In C++ also we have arrays, but mostly they are not used. Instead of arrays, vectors are used because vectors can be resized according to our need. You know that arrays have a fixed size. So this arr 100, this will it has a fixed size of 100, whereas vectors, they are resizable. So if you need more elements, it can be scaled up. If you need less elements, it can be scaled down. So mostly vectors are used. In some specific cases, arrays are also used. Wait, some people are joining. Okay, so how do we use the vector? We write hash include vector, then we write std colon colon vector, and then we specify the type. So since we want to create an integer array, we write int and then the variable name, and uh, this reserves some space for it for the beginning. So a vector, as we know, it can be resized. So it can hold 5 elements, it can hold 10 elements. Okay, but we can set a initial size also. So initially a vector size is 0, but we can set an initial size also, and that is specified by these parentheses. Okay, and then now we have the strings. Okay, so in C there is no string data type, like there is no special string type. A string is merely a character array. So in C, if we have to specify a string, we write char s and then the size of the array. Now this size, it has to be more than what you think the maximum size would be. So if you think that in some application your maximum string size is going to be 30, then you have to write here 30. Okay. Now the limitation is that since you are specifying the size from before, you cannot have a string that is larger than 30 characters. So the syntax is like this. Now one thing to note is that in C this string is null terminated. So suppose we have only the string hello. Okay, this will be stored as a character array where we have H, E, L, L, O, and then uh, we have the 0 character. Okay, so in the character array, it will be stored like this. Okay, so this is a 0 character, so it will be stored like this. Whereas in C++, we have a special string type. It can be included. It can be used by including the string header. Then we can define a string like this. Now you have to note that these C string and the C++ string, they are not the same data type. So you in like in some cases you cannot use them interchangeably. Now we talked about vectors in a previous slide. So these are some, and as I said that vector is a resizable array. So these are some common vector functions. So we have the size function which returns the number of elements in the vector. Then we have the empty function which returns whether the vector is empty. And then we have the begin and end functions which return an iterator to the beginning or the end of the vector. So now you might ask that what is a iterator? You can think of iterator as, for now you can think of iterator as a pointer. Okay, maybe iterators will be introduced in some future class. Then we have the pushback and popback functions. So these functions, these append an element to the end and end of the vector, and the popback function, it deletes the last element. Now you have this square brackets operator which can access or modify the ith element of this vector. So how do we use these functions? So first we have to define a vector. Let us say vector int arr, and then we add, now then we have to add some elements. So how do we add? We can use the pushback function for that. So we can use arr dot pushback 1, and then arr dot pushback 3. So this will add the elements 1, 3 and 5 to this vector. Okay, so after these three statements our vector will look like this. Okay, so now suppose we want to know the size, then we can write arr dot size. This will return 3 because there are 3 vectors here. Then arr dot empty will return false because the vector is not empty, it has some elements. And begin, if we use begin and end, then begin will return an iterator to the first element, and end will return an iterator to the last element. And we have already used pushback. Now if we use pop back, then the 5 will be removed from the array and it will be returned. And suppose we want to access the ith element of this array, we can write arr, suppose if we write 1, this will return as 3. Okay, this will return 3. So this square brackets operator, this makes it very similar to the arrays. Okay, but you must remember that arrays and vectors, they are like underneath all this functionality, they are not the same thing. But the square brackets operator, it makes it seem like the same thing. Okay, that is provided just for convenience. Now these are some common string functions. So these are for the C++ string type. Okay, C++ string type. So again, size returns the size of the string, and then begin and end do the same thing as the vector. Now one interesting function is this C string function. So this function converts a C++ string to a C string, and it returns the C string. Okay, so suppose you have some old function or some old piece of code, or let us say some old C library that accepts a C string. You can still use that library by using this CSTR function. You uh, you take the C string, you take the C++ string. Let us say s is equal to std colon colon string s equal to abc, and then you can use s dot cstr. This will return a pointer to the C string. Okay, and you can pass it on to some C code. Then you have the square brackets operator. Okay, which is again used to access or modify the ith character of this string. you also have this plus operator which can be used to concatenate two strings. So if you have two C++ strings ABC and DEF, you can use the plus character in between and it will concatenate them like this. Then these operators are also overloaded, the relational operators, and they can be used to compare two strings if needed. So the comparison is done in lexicographical order. Okay. Okay. Now sorting in C++. So how do we sort? So first, so for sorting we have to include the algorithm header file. Okay. And now we include the algorithm header file, and then let us say, like, we'll ignore this compare function for now, and let us say we have an array such as this. Okay, we can use an array, we can use a vector, we can use many things. Okay, but for now let us use an array. Then we call the sort function, which is part of the algorithm header, and we pass pointers to the first and last location. So the sort function, it accepts memory locations to the first and the last element which has to be sorted. Okay, so this data will point to the first one and data plus 5 will point to the end of this array. Okay, so this position, that is there. We ignore the compare function for now, and then we print the array elements. So let us say we do this, then the output will be sorted in ascending order. Okay, so the output will be 12, 12, 26, 32, 45, and then 71. Okay, so this will be the output. Now we'll talk about the compare function. So this compare function, this is an optional function. It is not mandatory to give it. Uh, but let us say we give this function. So if this function is given, then this function will be used to compare elements during sorting. So as you know that to sort an array or list, we need to compare the elements. So this function will be used if it is provided. Another thing is that this function is also used if we pass any non-trivial data type. Okay, here we have an array of numbers, but let us say that we have a array of some arbitrary type. Let us say we have an array of uh, I don't know, some other. Let us say we have an array of complex numbers. Now we know that complex numbers, they cannot be compared. Okay, so if you have two complex numbers, 2 plus 3i and 4 plus 5j, 4 plus 5i, ordinarily there is no way to compare these numbers. You cannot say that the which number is bigger, or I mean there is no standard way of comparing two complex numbers. So we have to specify a function which will be used to compare these numbers. So now that is why I have shown this compare example also. Now what will this compare function do? It should tell us whether one element is less than another element or not. So this is supposed to return a true false value. So the compare function, it will accept two values, let us say I and j, and it should return whether I is less than j or not. Okay, so here one example is shown. Um, in this case, okay, in this compare function, if I had written that return I less than j, then this would work exactly the same as the default behavior, and it would sort it in ascending order. Now if I want to sort it in descending order, all I have to do is I have to interchange the sign, and I have to, instead of this uh, less than, I have to give the greater than, which I have used here. Now because of this thing, the array will be sorted in descending order, and the output will be this. Okay, and we have a question which will use the compare function, so then it might be more clear. Now this is an example of sorting in C++ with vectors. Now most of the things are same. Okay, so in this case I have just included the vector thing, rest is same, compare function is also same. Now instead of an array I use a vector like this. Okay, and if you remember from the C thing, okay, I mean not C, the array usage, okay, we use data and data plus 5. Here we'll use data dot begin and data dot end. Now as we saw from a previous slide, the data dot begin and data dot end, they return iterators to the front and the end of the array. So it serves the same purpose as data and data plus 5. And then the compare function syntax is also the same. And then we print the array. So the last line it just prints this, I mean prints the vector. So this should give the same output as the last one, which is the vector sorted in descending order. Okay. Okay, now let us proceed. Next we have binary search.
Prathamesh, unmute your mic and ask.
Mm, okay, let us continue. So binary search. So again, binary search is part of the algorithm header. Uh, we need an array for this. Okay, array or vector. We need an array or vector, and we need a key which has to be searched. Now as you know that binary search only works with sorted arrays, so you must remember that this array must be sorted. Okay, even if the array is not sorted, it will not throw any error. Okay, there will not be any error, but the binary search function will not work properly. So we simply use this syntax, okay, binary underscore search, and again we pass the pointers to the front and the end of the array, and then we also pass the key which has to be searched in this array, and this returns the position of the key in the array. Now if the key is not found, then it will return a null pointer. Okay, so we can use this if else thing to check for that and print found or not found. So in this case, since 3 is part of the array, found will be printed. Now the same thing can be done with vectors also. Instead of the array, we include the vector header, and then we create a vector of the integers, and then we also get the key. And then similarly, instead of using data and data plus 5, we use data dot begin and data dot end, and then we pass the key. And again we can, like same way, since 3 is part of the vector, it will print found. Next we'll cover stacks. So to use stacks is already the stack data structure, okay, it is already part of the C++ standard library. Actually a lot of data structures are, So for that we'll include the stack header, and then we declare a new stack as this using this stack structure, such as stack and then data type and then variable name. Okay. So for vectors, you will remember that we used this syntax. So now here for stack we have to use the same syntax. Okay. Let us say s. Okay. So same syntax. So as all of you all know, so stack is a last in first out data structure. So because of that, it supports these standard stack functions, okay, such as push, pop, empty, and drop. So you know that push, it inserts an element, and then pop removes the element, and drop, it returns the last element, and empty, it returns whether the stack is empty or not. And now as I said, in C++, a lot of data structures are already implemented. So in most cases, you will not have to create your own data structure from scratch. You can use the inbuilt structures. So these are some inbuilt structures. So a vector is a array with automatic resizing. Okay. So you can think of it as a resizable array. And a stack is a LIFO data structure, and queue is a first in first out data structure. You also have priority queue. It is like a queue, but you can also attach a priority to the elements, and the elements with the highest priority, they will be dequeued first. And then you have the set data structure, which is a collection of unique elements in a specified order. And then you also have the map data structure, which is a collection of key value pairs in a specified order. You also, so this set, okay, this is like a mathematical set, like a collection of items. But the thing is that this is a it can only store unique items. Okay. So so okay. And then map stores key and value pairs. So those of you who know Python, this map is similar to a dictionary. Okay, in Python. And conceptually it is similar to a table. So you can think of a map as like a table. Okay, you have uh, several keys, and corresponding to the keys you have several values like this. Okay. Then you also have unordered set and unordered maps. So these are a collection of unique elements in no specified order and collection of key value pairs in no specified order. So you might ask why then, like, why two data structures set and map for this? So it is because the underlying working is actually different. So in set and map they use trees to, like, if you know data structures you will understand that in set and map they use trees to store the data. Okay, so they use trees like this to store the data, whereas in unordered set and map they use hash tables to do the same. Okay, so set and map have set and map have log n time complexity for uh, operations. Like set and map, they have log n time complexity for the common operations like insertion, deletion, and all. But unordered set and map, they have constant time complexity. Next, we'll go over some exercises. Okay, so this is the first exercise. You can like, if anybody wants to try, you can try on your own first, then I'll discuss the solution. Okay, so now let's discuss the solution. So Shikha and Shubham Raj, and Anurag, Prathamesh, Senthil and Vaishnav. Senthil. Okay, so they are correct. Okay, so the output will be 1, 2, 3, 4, 5. So how does this work? So we define a array IARR and the size is 5. So the array has 5 elements. So you can think of it like this. It is an array with 5 elements. Now we run a for loop here. So this is a for loop, and so this for loop it runs from 0 to less than 5, which means the for loop runs for 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, and now in this expression the RHS you can understand it is I plus 1. So I goes from 0 to 4, so I plus 1 will go from 1 to 5. And now the left hand side, so this is a dereferencing operator. Okay, so IARR it is a pointer to the first element of the array. So this is IARR. So this is IARR, it is pointed to the first element. So IARR plus I, it will okay, IARR plus I, it will point to the each individual element. So in the first iteration when I is 0, IARR plus 0 will be the first element only. Okay. In the second iteration when I is 1, in the second iteration when I is 1, then IARR plus 1 will be the second element. In the third iteration when I is 2, this will be the third element, like, and so on. Okay, and at the end when I is 4, then IRR plus 4 will be the last element. So that way we are going through all the elements of the array, and we are setting it to I plus 1, which means the array elements are set as 1, 2, 3, 4, 5. Okay, so this is the first loop. Now in the second loop you can see it's similar, but instead of setting the elements we are printing them. So we write C out and then we use the same syntax as this. So now the elements are being printed. So it will print the array contents and you will get 1, 2, 3, 4, 5 like this. Okay, so any questions till now?
No, sir.
Okay, okay, so one thing is that like while presenting it is a bit difficult for me to keep track of the uh, like the Google Meet. So if anybody has questions, you can unmute and in between also and ask. Okay.
Sir, explain again, sir.
Okay. So in the first line, okay, we create an array of 5 size. Okay. So let me see. I'm starting from the beginning. Okay. So in the I'll go line by line. So in the first line, we create a array of size 5. So now have 5 elements like this. Okay. Now then we have two loops in this program. So this is the first loop and this is the second loop. So now I will explain the first loop. In the first loop, the loop variable I, it goes from 0 to 4. Okay. Less than 5 means 0 to 4. So your I, it goes like this: 0, 1, 2, 3, and 4. Okay. So this is the I. Now we come to the second line. In this second line, the right hand side you can easily understand I plus 1. So I plus 1 will be 1, 1, 2, 3, 4, 5. Okay, it's simple. And in the left hand side, this is another way of writing IARR square bracket side. Okay, this is another way of writing this. Okay, so as you know, this accesses the ith element of the array. So what will happen is that the array elements will be set as 1, 2, 3, 4, 5 like this. Okay, so the array elements will be set like this. Now you can ask that how does this work? Okay, so it works as follows. The variable name, it points to the first element of the array. So variable name plus 0 will be the first element, plus 1 will be the second element. Okay, so this is plus 1 and this is plus 2. So like this it will go, plus 3 and plus 4. Like this it will go. And the star means a dereferencing operator. So these are all pointers. So when we put star in front of a pointer, we get access to the value of that location. So this is a dereferencing operator. Now in the second loop, the for part is the same. Okay, this is also same. This is the same as this. Okay, this is the same as this. So this basically prints the array contents, and we'll get this as output. 1, 2, 3, 4, 5 as the output. Now you might get one question. Okay, like in the assignment or in the exam, uh, something like you must remember that this is the same as this. Okay, so suppose you have x and y like this. Okay, you have x and y like this. Okay, where x is something and y is something, and it is put in square brackets. Okay, I mean here x should be an array. X should be an array or a pointer. Okay, not any custom data structure. It has to be an array or a pointer. So this, if you get, this is the same as uh, x plus y and the dereferencing. Okay, so in case of pointers, both are same. So you might get a question like this, because last year there was a question like this. So there is a question that should we enclose the output in square brackets? Which output? Okay, okay, okay. No, the output won't be enclosed in square brackets. The output will simply be 1, 2, 3, 4, 5, because the square brackets, they are not being printed. Okay, So any more questions, or you can also write it in the chat box. Okay, so there is a question that here the star is used as a pointer or not. Now the star is not used as a pointer here. The star is used to access the pointer's contents. Okay, let me explain here. So let us say you have some memory location and we have a pointer which, wait, some people are joining. Okay. So suppose we have a memory location like this and we have a pointer which points to that memory. Okay, now when we in any piece of code, suppose we just write ptr, then it refers to this pointer itself. Okay, it refers to the pointer itself. Okay, but if we write star ptr, then it accesses the memory contents and does something. Okay, so let us say we print it. Okay, if we print this star ptr, then it will print 2, and if we set star ptr equal to something, then this memory location will change to from 2 to 3. Okay, so you can think like this. Suppose this is some another memory location. So ptr is like this. So I can set ptr to the other memory location also. Okay, then the pointers, like the location where ptr is pointing, that will change. Okay, but if I write star ptr and change it, then the memory location is the same, but the contents will change. Okay, now let me continue. So this is the second question. You can try first. Okay, and then after 2 minutes I will discuss. Okay, now let me discuss the solution. So Divyansh is correct. So so in the first, we'll go line by line, okay? And there are some for loops, okay? Let me highlight the for loop blocks. So after a for loop, if we have like we are supposed to give curly braces, but if we have only one line, then curly brace is not necessary. It is the same as C, okay? So it is like this. Now let us go line by line. So in the first line, we are defining a vector called C vec with the arguments 3 comma minus 1. So here the first argument defines the initial size of the vector, and the minus 1, it defines the initial value of the vector. So your C vec, it will be initialized like this, okay? Minus 1 minus 1 minus 1, okay? So this is the initial value of the vector. Now we have a for loop, okay, which runs from 0 to 2, okay? I less than 3 means it runs from 0 to 2, and we set the ith value as I plus 1 into 10. Now I goes from 0 to 2 means I plus 1 goes from 1 to 3, okay? So 1 to 3 into 10. So after this for loop, your vector will become like this, 10 20 30. Okay, so somebody has asked, okay, so whether I can share the PPT. Okay, so the PPT will be shared with you, okay? You can find it on the, you can find it on the course website, okay? There will be a section on interactive sessions. From there you can find the PPT. I will upload it today. So after this for loop, CVEC will become like this, 10 20 30. Then we have the, then we have a line CVEC dot resize 3. So this will resize CVEC to 3 elements size, okay? Now CVEC is already 3 elements long, so nothing will happen in this line. Next line we have resize 3 comma 110. So what will this do is that this will resize it to 3, and it will fill all the elements with 110. So after this line, your CVEC will become 110, 110, and 110. Okay, it is resized to 3 and all the elements are filled with 110. So that is the meaning of this line. Now we come to the second for loop. Now the second for loop is a bit tricky because again we are running the loop 3 times from I equals to 0 to I equals to 2, okay? But we are not accessing the elements of the array, okay? What we are doing is we are using the pushback function. So you must remember that the pushback function, it inserts elements at the end of the array. So we are inserting I plus 1 into 20. So I plus 1 runs from 1 to 3. So 1 to 3 into 20 means 20, 40 and 60. So that will be inserted at the end of the vector, okay? So after this line, your CVEC will become like this. So 20, 40 and 60. This will be inserted like this, okay? And um, at the end of the, like this, the last loop, it will print this vector contents, okay? Now note that CVEC.size will return 6 instead of 3 because now there are 6 elements, okay? So the last loop, it will run for 6 times. So this loop, it runs for 3 times, this one also 3, but the last one will run for 6 times. because now there are 6 elements and it will print this. Okay, so Divyansh has answered it almost correctly. The last 3 elements will be 20, 40, 60. So if you have any doubts, you can unmute and ask, or you can write it in the chat box. Okay, now let me answer the question. So Veer has a question. But it is of a different topic. Okay, so I will answer it at the end. Okay, now Divyansh has asked that when he ran this code, it gave him 10, 20, 30, 20, 40, 60. Okay, so so if that is the case, then this resize, like this line, it did not affect the array. Okay, let me check once. Okay, okay. So he's saying that it initializes new elements. Okay, um, so it might be the case that when we use resize, okay, and we are increasing the size of the array, then the new elements are resize initialized with that. So let us say that we have a vector like this. Okay, 1, 2, 3, and we increase the size. Okay, so suppose we write resize resize this vector to 6 size, and then we specify 110. So now in this vector we have 3 additional spaces. So what will they be filled with? Okay, so in that case 110 will be filled over here. Okay, I think it is that is what it means. So like, thank you for correcting me. Okay, so if that is the case, then so the first line it will do nothing. Okay, cvec dot resize 3, and in the second one also, since the array size is not changing, so your cvec will remain the same. Okay, 10, 20, 30. So now the pushback, it does not affect the first few elements, so you will get it like this. Okay, 10, 20, 30, 20, 40, 60. Okay, so that is one question. And now I am coming to the pushback function. So the pushback function, it inserts, okay, so it adds new elements to the end of the vector. Okay, So let me explain here. Suppose I have a vector, okay, like this, 5 4 7, okay, and I use pushback. Pushback, let us say 12. Then this 12 will be added at the end of the vector. So after this operation, we'll have 5 4 7 and 12. Now after this, if I again write pushback 15, okay, 15 will be added after this. So this will be the final vector. So you can see that every time I use pushback, one element is added at the end of the array. Okay. Now over here, this loop, it runs for 3 times. Okay, and you know that the I, the value, the variable I, okay, it ranges from 0 to 2. So I plus 1 will range from 1 to 3. So this I plus 1, okay, so the arguments of the pushback, it will be I plus 1 means 1 to 3, and then that into 20 means uh, 20, 40, 60. Okay, yes, 20, 40, 60. So in effect, like 3 times the pushback function is called with 20, 40, 60. So uh, pushback 20, and then pushback 40, and then pushback 60. Okay, so 3 times the pushback function is called with 20, 40, 60. So that is why, so like before the pushback, okay, the vector was like this, but after this pushback, the 20, 40, 60, they are added at the end. So the final array will look like this: 10, 20, 30, and then 20, 40, 60. Okay, so I hope that is solved now. So now we had a doubt about type def, double and num3. So Veer, have you written it into a compiler and compile it, because I think this is not correct. Okay, because type def is used to uh, like redefine or create a new type. So this is Veer's question. So you have type def double and num3. So I think this is probably not syntactically correct, uh, because like this is supposed to be the type. Okay, so how are you putting 3 over there?
Sir, actually, it's an assignment question.
Okay,
I had the same doubt.
I don't know actually. Okay. So I don't know about this one. Okay, but but I can guess. Okay. So this is the question. So probably what will happen is that like a collection of three doubles, it will be defined as the type num. Okay, so num will be equal to three doubles. Okay, three doubles, and now we are defining a five size array of nums. Okay, so what will happen is that you will kind of get a 2D array or a matrix. Okay, you will kind of get something like this where we have three columns and five rows, because the num data type, it will be uh, the num data type, it is a double of size 3. Okay, the three doubles, and then we create five elements of that, five types of that, so it will be kind of like a 2D array. And now we are assigning these, we are initializing it with 1 2 3 4 5 6. So the first, uh, now you must know that the array assignment is done in a row major order. uh, the assignment will, wait a minute. Assignment will be done in a row major order, so the first elements will be like this, 1 2 3. The second row will be like this, 4 5 6, and the next rows. Okay, so rows 3 4 and 5, they will not be defined. Okay, so if it is in the middle of the program, like in the middle of some function or something, then it might have garbage value. Okay, so the rest of the elements, it might have garbage value. But if this is a global array, then the rest of the elements will be initialized to 0. Okay, so like if I assume that this is a global variable, which means it is declared outside any functions, then the memory will probably look like this. You will have 1 2 3 4 5 6, and the rest will be zeros. Okay, so this is a zero matrix of size 3 cross 3. Okay, but if it is a uh, yes, like Arun is correct in this case, so this, it will be like this. But if it is inside a function, okay, then there is no guarantee that it will be 0. It might have this 0, like this portion might have garbage value. Okay, okay, yes, Vaishnavi has written a comment. Okay, so this is correct. Okay, so if you write type def double num and then if we define the array with num array 5, then it will be an array of 5 doubles. Okay, then let me continue. So this is the third question. Please try on your own. Okay, now let me now solve the question. Okay, so we have a function called modify, and it accepts a pointer to an array. So you can think of it like it accepts the array only. Okay. Then we are calling the rotate function, uh, which rotates the, and then we are calling the rotate function which will rotate some part of the array. So now what does this rotate function do? It rotates the array contents in cyclical manner. Okay, so suppose you have 1 2 3 4 5. If you have array like this, it will rotate the array contents in a cyclic manner. So this will be the, like, without any of these fancy arguments, it will work like this. Okay, but what we can also do is we can specify the starting and ending point of the rotation. So that is what we have done here. Okay, now I will erase this. Okay, so ARR plus 3 means, okay, so this, if we denote the array positions, okay, so here I'm writing the array positions. So the array positions are like this. Okay, and 5 is the end of the array, so it is beyond the last element. So ARR plus 3 means this one, so it means 4, and ARR plus 5 means the uh, end of the array. So it will rotate the elements which are in between these two. Okay, uh, so okay, so it will rotate the elements in between these two. So after the first rotate call, so the first three elements, it will be the same. Okay, and this 4 and 5, they will be rotated, so it will be like this. Okay, and now what we are doing is we are rotating ARR plus 2 and ARR plus 4. So ARR plus 2 means this location, and ARR plus 4 means this location. Okay, so in between these locations, whatever is there, it will be rotated. Now one thing is, wait a minute, yes, one thing you must know is that the when we specify in all of these C++ functions, when we where we have to specify a starting and the ending point, the ending point is excluded. Okay, the starting point is included, but the ending point is excluded. So in the first rotate call, you can see ARR plus 3 and ARR plus 5. So as you saw from the example, the 3 location it is included, but the 5 location is excluded. So then you, when you rotate it, you get 1 2 3 5 4. Now in the second one, we have ARR plus 2 and ARR plus 4. So 2 will point to this 3 and 4 will point to the last element, but this last one, it will be excluded. So your 3 and 5, it will be rotated. So this is what you will get. Okay, so this is the answer. So any questions on this one?
No, sir.
Okay, then let me continue. So this is the next question. Please try. So this question is about 1 2 4 5 3. Okay. Okay, okay, okay. Okay, thank you for the correction. Okay. Thank you for the correction. So this error plus 3, so this will become the new first element. Okay, so it will be 3, 4, 5, and then 1, 2. Okay, and then um, so after the first line it will be this. Okay, and after the second line the 5 will come in the beginning. No, wait. Yes, then the answer should be this, right? Um, yes, so after the first function call we get 3, 4, 5, and then 1, 2. But then Divyansh, can you explain?
Hello. Hello. Am I audible, sir?
Hello?
Hello. Good evening, sir. Am I audible?
Okay, okay, so after the first rotation, okay, okay, now I understood. So ARR plus 3 will become the new element, so it will be 4, 5, 1, 2, 3. And then in the second rotation, we are rotating on, we are excluding the last element, and so it will be 1, 2, uh, 1, 2, 4, 5, 3. Okay. So okay, so thanks for clearing it up. Okay, so the So the thing is that when we use the rotate function, it rotates the array in cyclical order. Okay, so the first argument it gives the pointer to the array, and the last argument it gives the end pointer of the array, like the end pointer of the range that we have to rotate, and the middle pointer it it gives how many rotations to be done. Okay, so in the first rotation we are rotating between ARR and ARR plus 5. So basically the whole array. Okay, we are rotating the whole array, and then we are writing ARR plus 3, so it means we have to rotate it 3 times. So let me explain here. So our initially the array is like this. So in the first function call we have array ARR and ARR plus 5, which means we have to rotate the whole array, and then ARR plus 3 means that we have to rotate it 3 times. So this is the initial array. So if we rotate it once, we get this. If we rotate it twice, then we get this, and if we rotate it 3 times, then we get this. Okay, so after the first rotation after the first function call we'll get this. Okay, so this is the first rotation, this is the second rotation, and this is the third rotation. Okay, uh, which I have written here 4 5 1 2 3. Now in the second function call we are writing ARR and then ARR plus 4. So here we are not rotating the whole array. ARR and ARR plus 5 means we are rotating the whole array, but ARR and ARR plus 4 means we are excluding the last element. So the whole array except for the last element. Okay, and ARR plus 2, which is the middle argument in the middle, it means that we have to rotate it 2 times. So our new array is this 4 5 1 2 3, and over here we are rotating only the first 4 elements. Okay, we are excluding the last element, and we have to rotate this 2 times. So after the first rotation we will get this. So again you can see I'm only affecting the first 4 elements, and now we'll rotate it another time. So we'll get this. Okay, so this is the final answer. Okay, now let me continue. So this is the next question, and uh, this question is about the custom compare function. So using a custom compare function. So please try it on your own first. Okay, then I'll discuss it.
Sir,
Yes,
sir, so what was the answer of previous question?
this one 1 2 4 5 3. Okay, now let me discuss this question. So here, so the compare function, it tells us whether one element is less than another element or not. Okay, for any two general elements. So here you can see that we are using I by 10 and I mod 10. Again j by 10 and j mod 10. So if you have any number, okay, if you have any number, then I by 10 will return the, okay, so I mod 10 will return the last digit, right? And I by 10 will return the second last digit. So in a way, the this is the sum of the last two digits, and this is again the sum of the last two digits. So uh, we are comparing based on the sum of the last two digits. So it will be helpful to write down all the sums. Okay, so the array is like this, and the sum of the last two digits are uh, 9 9 uh, 9 9 5 4 and 6. 9 9 5 4 and 6. Now the compare function, it tells us which one is lesser. Okay, so the the element which has the lower sum of last two digits, it will be placed before. So that is why the 40 will be placed in, like after the sorting is done, 40 will be placed in the beginning, then 32 will be placed, and then 51 will be placed. Okay, and after that 18 and 27 will be placed. Now you might ask that what is the order of, like, since by this logic, okay, 18 and 27 they should be equal because both have the same last, like sum of last digits. Okay, so they should be equal. So the thing is that it can be placed in any order. Okay, there is no guarantee that it will be placed as 18 comma 27 or 27 comma 18. Okay, so in the original array, if you see in the original array, 18 is before 27. Okay, so you might say that, okay, since in the original array 18 is before 27, in the sorted array also it should come like that. uh, but if we use the sort function, there is no guarantee. So here both the answers are correct. Okay, so here we have two possible answers. Instead of the sort function, if we had used the stable sort function, then there would be a guarantee that uh, 18 will come before 27 because it comes before 27 in the original array. Okay, so here we have two possible answers which are correct. So any questions on this one? Okay, then I'll continue to the next question. So this is the next question. Please try on your own first. Okay, now let me answer this question. Okay, so first we need to know what does this replace function do. So this replace function is like your it is like your find and replace utility in almost all softwares that you use, like in Word or in VS Code, anywhere you have a find and replace function. So this function works in the same way. So you have the first two iterators which specify the beginning and end of the range where you are supposed to the find and replace. So if we have to find and replace something, we need to know where to look, right? So the first two arguments, it specifies where to look, okay, so the beginning and end. And then the third argument, it specifies what to find, okay, this is like the find part. And the last argument, it specifies what to replace it with, okay. So if I write it like this, then this is like the start and the stop of the range. So the start and stop of the range, and then we have what to find, and then we have replace with. Okay, so this is the syntax. Now then you can, I mean, not the syntax but the function signature. Then you can like solve this step by step. So first we have an array like this, and then we are finding the size of the array, which is size of this by, like, this is a way of finding the size of array. So n is equal to 5 in this case. Now note that this for loop over here, it runs for 0 to I less than n by 2. So n by 2, since n is an integer, so n by 2 is equal to 2, okay, because n is an integer. And I runs from 0 to less than 2, which means I runs, like, it runs 2 times only. This loop, it runs 2 times, okay, for I equal to 0 and 1 only, okay. Now we set temp equal to I data. So let us do both the iterations, like, since there are only 2 iterations, so we can solve it like this. So now I am doing the first iteration, which is I equal to 0. So then temp will be equal to I data 0, which means the first element. So temp will be equal to 1. Now we come to the first replace clause, okay. So here we have I data comma I data plus 5, which means the whole array. So look in the whole array. Then what do we find? We find temp. So in this case it is 1. So we have to look for temp. And what do we replace it with? We replace it with this thing. Now, as I said in a previous slide, so this is equal to, this is the same as I data n minus I minus 1. So here I is 0, so I am writing as n minus 1 because I is 0. So I data n minus 1 means the last element, okay, this element. So like you can understand, right? So now what to find is, we are looking for 1, okay. So we are finding ones in the array, and we have to replace them with 5. Now there is only one in the array, which is in the first place, and we replace it with 5. So after this first call, the array will look like this: 5, 2, 3, 4, 5. Okay, this is how it will look after the first replace call. Now we go to the second replace call, and in the second replace call you can see that the end position is the same, okay, but the first position has changed. It is I data plus I plus 1. So I is 0, which means I data plus 1, which means look from the second element onwards, okay. So we now have to search from the second element onwards till the end of the array. And now what do we look for? We look for this, which in this case is the last element. So the last element is 5, so we search for 5. Okay, then we replace it with temp. Now temp is 1. So here in this range you can see that there is only one 5. So we replace it with 1 and we get this. Okay, 5 2 3 4 1. So so this is what we get after the first iteration of the big loop. Okay, of the big loop, after the first iteration we get 5 2 3 4 1. Now we do the second iteration, which is I equal to 1. Now here again your temp is equal to I data I, so temp will be equal to 2. And now we come to the first replace call, which is here we are looking in the whole array, the whole range, and we are looking for 2's, and we'll replace them with the second last element. Okay, because I is now 1, so now it is looking for n minus 2. Okay, so we have to look for 2's and we have to replace it with the second last element, which is 4. Okay, so and remember that our array is now this. Okay, so after this replace call we'll get this. Okay, and now we do the second replace. Okay, now we come to the second replace call. Here we look from the uh, I data plus 2, which means we look from the third element onwards, third element till the end of the array, and we look for the element 4 and we replace it with 2. So we get 5 4 3 2 1. Okay, so the final answer is 5 4 3 2 1. Okay, so now Divyansh has asked a question. Let me check. So which question is it? Uh, okay, so I don't know what does it mean. It is working, right? So all the cases are like don't share the solution here, okay, because others are also here. But if it is working and it is passing, then it's fine, I guess. Okay, then I would like to conclude today's session. So thank you for attending.
Thank you, sir.
Thank you very much, sir.
Sir, I have a doubt.